This is pre-calculus. This section, we're going to discuss exponential functions. First, what is exponential function? Exponential function form is a little different from polynomial function. So when you talk about exponential function, guys, pay attention here, base. Base gonna be positive. It can be 1. X is gonna variable on the exponent. That's the difference from polynomial function. So base is number, power is variable. That's what we call exponential function. Very clearly understand that? So for example, what is exponential function here, guys? Look at this one. What is a base? Base is 3. Positive, right? Here is a base, 1 over 3. Base is 1 over 3. Here, base gonna be 0.5. So that's the base. Base is positive greater than 1. What is not exponential function? What is base? Base is x, power is number. We call this is a polynomial function. So can you see this one? 2 to the x. That's the exponential function. This one is a polynomial function. Base is negative 1/3. That's negative, so this is not. Base gonna be negative 1/3. It's not exponential function. Base gonna be 1. Base is 1 is not exponential function. So understand that base is greater than 0. Base cannot be 1. Power is variable. That's the exponential function. Now, how gonna graph the exponential function? You can use scientific calculator. You can Google how to use a scientific calculator. You can look up my lecture note. So let's say let's gonna fill out this table to sketch the exponential function. First, you notice here, guys, here is B. We have 2 different base. First is base is greater than 1. Second is this one is rewrite it. Here is a base, right? Base gonna be 1.5 less than 1 greater than 0. Guys, review exponent property. If you guys remember, a to the x negative x is a to the negative x gonna be 1 of ax. Same thing is 1 of ax. Or the same thing, okay? Power is negative, then you're gonna send the base to the denominator, and then you have fraction form. So 2 different base. Let's calculate. You can use calculator, scientific calculator, and then Google how to use it, guys. Here is a 2 to the negative 2. That's the 1/4. Here is 2 to the negative 1, meaning is 1 over 2. 2 to the 0 gonna be power. Always, power is 0 is always 1, not 0, guys. 2 to the 1 is 2. 2 to the square is 4, right? Then you can sketch it. Negative 2 and 1/4. Negative 1 and 1/2. 0 and 1, 1 and 2, 2 and 4. So you're gonna sketch this one. Exponential, whatever you plug in the x value, this cannot be, y value cannot be 0, but never 0. So you're gonna sketch this. Okay, that's the y equal e to the x. Let's give you a couple of things here, guys. What is domain? Euler number. What is range? Range, 0 and infinity. Horizontal asymptote. Can you see the x go to this direction? Left, go to the left. This graph never touched this line. What is the name of this line? Y equals 0. That's the important property. How about another one? This is increasing. X go to the right, y is go up. That's the increasing function. That's first part we sketch. Let's go g of x, 1.5 x. Let's find the value. So here is a 1.5, negative 2. Gonna be this is a 4. 1.5, -1, that's the 2. 1.5, 0 gonna be 1. 1.5 for 1 is 1.5. 1.5, 2 gonna be 1/4. All right, put in 1. So you have here, 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 -1 and 2, -2 and 4. Okay, let's just sketch it. What kind of the characteristic you can find here? Domain is the same. Range is the same. Horizontal asymptote is the same. What is different? That's the decreasing function. Have you understand the base is greater than 1 increasing function, base between 0 and 1 decreasing function? What kind of characteristic between, what kind of relation between two functions? This one is reflect over y-axis, guys. That's the really important relation between two functions, and then all the characteristics of exponential function. I summarize it, guys. B of x gonna be here, base gonna be b. Depends on b value. B is greater than 1, b is between the 0 and 1. B is greater than 1 is, you say, increasing function we call growth function. That's the graph is here. Increasing function right here. B is 0 and 1. That's gonna be decreasing function right here. That's the decay function. Every characteristic is same. Domain is all real number, range is 0 and infinity, horizontal asymptote is y equals 0, x-axis, y-intercept is 0 and 1. That's the characteristic exponential function depending on the base. Let's do the transformation of the parent function. So quick review from algebra class. So this f of x is parent function. You're gonna move up, go to the left. Go to the left is 1, okay? Go to the left is 1. So how can, look at this graph. This one is, they go to the left to this side is 1. I should use different. Go to the left is 1. So guys, remember, original function is y equal f of x. Go to the left, go to the right. You're going to change inside. Go to the left to c. Go to the right to c. Then function going to be y equal x plus c. Let's go to the left. Go to the right, going to be y equal f x minus c. That's you do the transformation here. So this one is go to the left. So original function is f of 3x. We have function g of x going to be, original function is f, go to the left 1, x plus 1. So that's you have 3x plus 1. So when you translate, go to the translation horizontally, what do you change here? Domain? Domain is the same. Domain is all your number. Range is 0 and infinity. Doesn't change anything. Next example is you're going to move down. Move down, move up. So let's review move down, move up. So y equal f of x. When you move up, d unit, y equal fx plus d. When you move down, y equal fx minus d. That's the transformation vertically, right? Now, this one is move down. How much move down? 2. This is horizontal asymptote line. Move down. How much is 2? So this one gonna be y equal g of x function gonna move down. Original function is 3 to the x. 3x minus 2. Let's move down. Then very carefully see what gonna be changed this one after transformation. Domain doesn't change, right? How about range? Range is gonna be now. What is minimum? -2 and infinity. What else here is changed? Horizontal asymptote also move down. Y equal -2. That's the transformation of exponential function. Now, next one is we're gonna talking about natural exponential function. one of the most important function in the science and engineering, guys, okay? What is a natural exponential function? So natural exponential function is base gonna be e. E is irrational number. E gonna be never, that decimal is never stop. That's gonna be we call base gonna be e. This one is gonna be natural exponential function. This one is natural base. That's a irrational number 2.71828. Keep going. So this value gonna be, as you see, this e gonna be always 1. Then we have characteristic of exponential function, two different things. Base gonna be greater than 1, base gonna be 0 and 1. So let's check this value on your own calculator. You can Google it, or you can check my lecture note how to calculate, evaluate the natural exponential function. Okay, so e to the negative 2, we're going to find the 3 decimal place, 0.135. E to the negative 1, 0.368. E to the 0 is always 1, guys, always 1. E to the 1 gonna be 2.718. E square gonna be 7.389. So let's sketch this one first. So e to the negative 0.135. Right here, e to negative 1. Right here, 0 and 1. 1 and 2.78. 2 gonna be 7 something right here. So you're gonna sketch it. So very similar shape from previous one we did, right? Because b is greater than 1, that's the increasing domain, range, horizontal asymptote, exactly same. G of x, e to the negative x. Here is gonna be, you're gonna find this one, e to the negative 2, then here, 7.389. E to the 1, 2.718. E to the 0 is 1. E to the negative 1 is 0.368. E to the negative 2 gonna be 0.135. So you're gonna sketch this one, the other side. Then you're gonna see, oh no. So you're gonna see 1 here, 2 is right there, 0 here, here. That's the exponential e to the negative x. Y equal e to the negative x. The other one is y equal e to the x. So can you notice something here, guys? Domain range, horizontal asymptote is the same. What do you notice? This one is refract over y-axis. When you refract over y-axis, that's going to be change x sign. That's another way to sketch the exponential function here, right there, guys. So last part of this video is we're going to do application problem. When do you use exponential functions? So many different ways use it. Population growth or investment growth, something like that. We're going to use it, but I give very simple application problem. This one is going to be population growth. Here is growth function. Growth function meaning is what, guys? Increasing function. So that's the base. I already give the function right there. Here is b value. Here is b value. What it represents here? Number 316. If you read correctly, guys, United States population approximates 310, 2010. 0.97 increasing, that's growth function. So we have approximated this function. So when you see this function, that's the growth function, you notice it. B value gonna be 1.0097, that's greater than 1, that's the growth function. So you're gonna say first answer gonna be graph for P of t, increasing, decreasing exponential function. Of course, that's the growth. Why? B value 1.0097 is greater than 1. That's the growth function. Let's go to the B. They want to calculate the P of 0. T equals 0. What does T equals 0 mean? T equals 0 meaning is 2010. That's the starting point. So you plug in T equals 0. This value going to be always 1. 310. at t equals 0. So 2010 population is 310 million. That's exactly that number. Next one is C. Okay, t equal 10. What is t equal 10? After 10 years. 10 years after 2010, then 2020. What is the population going to be? 310, 1.009710. Guys, make sure how to use calculator, how can calculate this exponential value, guys. Then you're gonna have, you're gonna have 3.1 million. So after 10 years, your population gonna be increasing to the 3.1 million. Last one is you're gonna try to do both, guys, okay? P20, let's do 20, 310, 1.009720. That's population gonna be 376 million. What do you mean by that? After 20 years, from 2010, population gonna be 376 million. That's a 2030. So 2030, population gonna be 376 million.